needs to know how to do it. And keep in mind that there are plenty of R packages to make these fits. Here I'm reporting a reference to the Kolmogorov-Smirnov test, which is a test that is frequently applied, and it's very simple. It's based on the comparison between probabilities, and in this case it's cumulative probability, and frequency. If the distribution is fitting the data well, it should deliver an estimate of probability that is close to frequency. Usually there is a difference. You have to check that this difference is limited. So you see the black arrow there. It's the difference between frequency, which is computed and increases by steps, because it's computed over intervals, and the probability. You have to check that the difference is small. And there is the link to the Kolmogorov-Smirnov test. Have a look, but this is not a question that I ask at the exam. Okay? So I suggest you to have a look, because it's important that you know what statistical testing it is. But again, I'm not asking the question at the exam. Keep in mind that you can use this distribution to extrapolate. You can put here whatever return period you want. You can put 100,000 years here. But when you go with the return period to longer time steps than your observation period, you are extrapolating. So the time series of the Port-Iver is extended 90 years. If you compute the peak flow for a return period of 100 years, you are already extrapolating. Extrapolation is something that is always uncertain. You don't have to exaggerate. There is a rule of thumb that says that extrapolation shouldn't double the observation period. So your return period shouldn't exceed twice the observation period. Sometimes we do. There is one positive feature of the Campbell distribution. In extrapolation, usually it overestimates. This is one of the reasons why it's used, because it's safe. Furthermore, keep in mind that, and read here, you may incorporate the physical basis, like if, as I mentioned, if you know that the catchment is changing, that the river regime is changing, you can correct your estimates. And look, we don't need to, this is a descriptive discussion, a descriptive treatment here, as you see, so we don't need to discuss it in details, it's just sufficient that you read. And finally, for the peak over threshold, I just want to mention that is a completely different story. I just want to mention that there is another distribution that you should use. This one. You don't need to learn it by memory. And I may ask you, what are alternatives to using the annual maxima? And you should just say, we can use peak over threshold, and we need to use another distribution, like the generalized Pareto, like it's written here. Finally, there is the final part of this page, which explains how we can estimate the peak river flow with alternative methods to probability. And this is not a subject for the exam, but I suggest you to have a look, because in this way you get a complete overview of what are the tools that you have available from the literature to estimate peak flows. It's something that I suggest you to read, not to study, but to read. Okay, so let's meet tomorrow at 11 in the morning then, and then on Friday we conclude.